Hello everyone, I hope you are doing well. It's Wednesday. Hope everybody is staying sane and doing some math. So I've gotten some questions from some of you about how to do some of the problems on the mixed review, as well as some of the derivative problems. So I figured I'd check in and help you guys out with a few of them. For those of you interested in seeing my dog, there's my dog. Hi, Poppy. See, she's alive. That's very exciting. She's just hanging out and doing her thing. But we got some fish over there. That's exciting. And here's me, and that's not as exciting. But let's get to some math. The first question somebody asked about was one that looks like this. On which interval is f of x equals 2 over the square root of x minus 1 not continuous? This is the thing that we really care about, this 2 over the square root of x minus 1. If we plug 1 into this thing, then we would get 2 over the square root of 0, which is 2 over 0, which is undefined, which means that the function doesn't exist when x is 1. So if we look at these different options, if I include the value 1, then my function would no longer be continuous. Now, everywhere after that, my function would be continuous, but at the specific number 1, my function is not continuous. So this is the one that includes a value that I'm not allowed to include to make the function not be continuous. So that's the one that I would be interested in. The other problems dealt with derivatives. People asked about some problems in the workbook. So let's start by looking at problem number 24, which asks us to take the derivative of this guy, which is 3x squared minus 2xy plus 5y squared equals 1. So we have 3x squared minus 2xy plus 5y squared equals 1. So if we're taking the derivative of this, I've got x's and y's, which means I'm using implicit differentiation. So this is going to become 6x, pretty straightforward, minus, be careful here, I'm subtracting an entire thing. I have the first multiplied by the derivative of the second, which is going to be dy over dx, plus the second, which is y, multiplied by the derivative of the first. Now, note I already put this negative here, which means I'm not going to put a negative here. So the derivative of the first is going to be just 2. Plus, this is going to become 10y, and then because we have to multiply by the chain, we would have dy over dx equals 0. Remember, technically we multiply by the chain here, but because we're taking the derivative with respect to x, it's technically dx over dx, which we don't really care about. So don't worry about that. Since I'm asked to find the derivative, I want to get dy over dx all alone. So I'm going to distribute this negative through, and I'm going to remove everything that doesn't have a dy over dx in it. So on the left-hand side, I'll still have negative 2x dy over dx. I'll still have plus 10y dy over dx. I would have to subtract this 6x from both sides. So this would become a negative 6x. And this is really a negative 2y because of this minus sign, which means that I would have to add 2y onto both sides. So I would have this thing. I would then factor the dy over dx out. So I have dy over dx multiplied by negative 2x plus 10y equals this thing. And I would end up dividing by that value, which means that I would have dy over dx equals negative 6x plus 2y divided by negative 2x plus 10y. Now, if you look at your answers that are listed in 24, you'll notice that none of them look quite the same as the values that we're looking at here. That's because these fractions have been reduced. Over in this problem, all of these are divisible by 2. And so if I divide everything by 2, I'm just reducing my fractions. And so this would become negative 3x plus y, and this would become negative x plus 5y. So I see that there's a 5y minus x and a y minus 3x, and that would be the answer that I'm interested in. The next question that somebody asked about was problem number 29. Problem 29 says, if a point moves on the curve x squared plus y squared equals 25 at 0, 5, what is the second derivative value going to be equal to? So I have x squared plus y squared equals 25, and I need to take the second derivative of that thing. So I'm going to end up with 2x dx over dx plus 2y dy over dx equals 0, which means that dy over dx would equal negative 2x over 2y, so that equals negative x over y. That's the first derivative, but they asked us to evaluate the second derivative, so we're going to take the derivative of this thing again. So d squared of y over dx squared is going to equal low d high, which is going to be y multiplied by negative 1, minus high d low, which is going to be negative x multiplied by the derivative of the low is going to be dy over dx divided by the low squared. Now here you have to be careful. Because you have this dy over dx right here, we already know that dy over dx is this thing. We're going to substitute this into this value. So we end up with negative y. I'm going to take this negative and turn that into addition. I have x multiplied by negative x over y would become negative x squared over y divided by y squared. And this is what they asked us to evaluate at the point 0, 5. So all of our x's will become zeros, all of our y's will become 5, so that means that this thing doesn't really matter. And we end up with negative 5 over 25, which is negative 1/5, which is D. Right there. The last problem that somebody asked about was problem number 72. So let's take a look at it, see if we can figure out what's going on. Okay, so this is one of those problems where they give us a bunch of instructions in regard to one graph. Use the figure to answer 70 through 72. The graph of f consists of 2 line segments and a semicircle. So here's our semicircle right here. They want us to find f prime of 5. So we want to find the derivative of this thing at 5. Now, you might ask, how in the heck am I supposed to do that? Well, first of all, you know that your slope is positive. That unfortunately doesn't help us very much. One thing that we could do is we could come up with an equation for this thing right here, this semicircle. So we know, let's go over to a sheet of paper so we can do some work. In our problem, we've got this circle. We don't really care about this thing at all. So let's just deal with this portion of the circle. We know that a circle can be written generally in the format x squared plus y squared equals the radius squared. And the radius of this thing is 2, which means that this would equal 4. And if we solved something like, or if we wanted to write an equation for this circle, this would be a circle that's been moved right 4 units, which means that we would have x minus 4 squared plus y squared equals 4. Now, this would be the equation of this thing as a full circle. But if we want the equation just of the bottom half of that, let's get y all alone. Y squared would equal 4 minus x minus 4 squared. Then we could take the square root. Now, normally we would put a plus or minus in front of here, but that would be if this thing was an entire circle. This is only the bottom half of a circle, which means that we're only interested in this bit of our circle. At this point, this is our equation of this semicircle. And we were asked to find the derivative of this equation at 5. So I'm just going to take the derivative of this thing. I've got a negative square root out in front, so I'm going to have negative 1 over 2 times the square root of 4 minus x minus 4 squared multiplied by the chain. And the chain is going to be the derivative of the inside. If I take the derivative of the inside, I don't really care about this thing at all. This is going to become 2 multiplied by x minus 4 to the first power. I could put a little 1 there if I want to, but I don't really feel like it. Multiplied by the chain again, because the inside is differentiable, but the derivative of the inside is 1, so we don't bother writing that. So this is dy over dx. We can clean this up a little bit, cross out those 2's. And we were asked to find the derivative value at 5. So we just plug in a 5 into this thing. So we have negative 5 minus 4 divided by the square root of 4 minus 5 minus 4 squared. Well, 5 minus 4 is 1, and 1 squared is 1. So we end up with, something's not right here. Negative 1 over the square root of 3. I know that something's not right because of the fact that this is negative. This can't possibly be a negative value because at 5, I can see that my slope is positive. So, looking at this, let's see if we can figure out where we made a mistake. We have x minus 4 squared plus y squared equals 4. We subtract that value. We take the square root and it becomes a positive and a negative. We're interested in the negative one. The derivative of this, I wouldn't lose my negative, so I'd still have negative 1 over 2 times the square root of 4 minus. There's my issue right there. So in this portion, when I multiplied by the chain, I made a mistake. I should have had this negative come along for the ride on the chain, because the derivative of this would be, because this quantity is 4 minus the quantity x minus 4 squared, the derivative of this is going to be 0 minus 2 times x minus 4, which means that there should be a minus here. And because there's a minus there, that means that there's going to be an extra negative, which is going to turn this into a positive, which is going to turn this into a positive. Now, note, how did I notice that I had made a mistake? How did I know that I had made a mistake? Well, because I was looking at the original problem and I understood what was going on in the original problem. I know that at 5, my slope has to be positive. So if my slope has to be positive, there's no way that I should just be getting a negative value as my slope. So at that point, I'm going to look for where I made a mistake, and I'm going to try to fix it. We all make mistakes. Hopefully, everybody's doing all right. I'm sure you've seen the posts about the AP test now being only free response. So my guess on what it's going to look like is 3 free response questions. I have unlocked all of the practice free response questions in the College Board website. So if you want to practice with those, that's where I would recommend spending my time. If I'm picking and choosing where I'm going to spend my time, that's where it would be. Keep on working on refamiliarizing yourself with limits and derivatives, particularly since we've spent so much time on integrals recently. I would really focus on things like rules of continuity. That would be worth knowing. That's something that they often ask questions about. We'll keep on throwing problems at you, and hopefully people keep on getting more and more comfortable. I hope you all are doing well. I hope you all are staying away from everybody else, but that everybody's staying sane and happy and all that business. I will talk to you all again soon, and hopefully this was helpful, and you hopefully enjoyed it when I messed up, because everybody likes it when Mr. Collier messes up. Have a wonderful day, and stay well, everyone. Bye.